Welcome guys. We're going to be talking about a tailstock today. This was requested by a customer. So quickly to start, when it comes to the tailstock pressure, how much pressure you're gonna use, you're going to go into the wrench. You're gonna pick that icon that looks like a tailstock, and it says tail thrust. So you have 225, 450, 675, 900, and 1125 pounds of pressure. And the way that actually the tailstock works is that if you have a part, right, and you have a little center, you're gonna bring the tailstock in. This is gonna be that center. That tailstock has constant pressure on that part. If by any chance the part gets pushed into the spindle, for example, there's a sensor, pressure sensor. Once it senses that the pressure is gone, the machine will actually automatically stop to pretty much, so let's say it stops the accident from happening from, let's say, long part flying out of your chuck and or maybe something worse, right? So there's some preventive measures. So the tailstock, when in an automatic, it's constantly applying a pressure into the part. Now, the older so you have two types of way to actually move the tailstock. Sometimes it's gonna be two switches. Over here we have a knob. So clockwise, you send it back home. Counterclockwise, so turning left, you're gonna engage it. The light is always going to be on. If it's not home, it's not gonna allow you to actually run a program. It's not gonna be cutting. So as it has the green on the right, that means it's home. The green on the left of the switch, as you see there's a little icon, that means it's engaged in the part. We have also different type of centers. So you see a large center over here. This is what you call a life center. The reason why is because you have bearings over here. So you see that this is actually movable. These centers with bearings, if you have a smaller center like this, the actually bearing it's gonna be much bigger. It's gonna have the bearing actually right in the front, but since this one is big enough, it's actually built in. This is what you call the dead center. There's no bearings, it's just a simple piece of center. So it's not moving. And also when you're buying your center, Mazak uses, from what I remember, a Morse taper. So there's a very specific taper when it comes to the actually taper, as you see over here. There's different ways of removing the tailstock, removing the center. So for example, you have a small center, which will allow you to clear better if you're working on a thinner parts. Or you have large centers like this, as you see, for bigger parts. This, for example, has a system when you have a knob, where you have a nut, and the way you do it is you have a flat where you can put the wrench over here, and then you screw this in. Once it's screwed all the way in, it's gonna actually end up on the body of the tailstock, and with the turn you're gonna yank it out. Bigger tailstocks like this, you can use like a rubber mallet, or like, for example, a wedge, which kind of looks like this. So what you would do is you're gonna go, let's say you wedge between the body of the tailstock and between this part, you're gonna hammer it, and as you see, as this is gonna expand, it's gonna put the pressure in, it's gonna pull it out. But like I said, this one will not work on my Mazak because the taper is different, and obviously this is for manual type of a tailstock. These are actually from Mazak, also have a bigger one as well. So these are pretty much just kind of basics. One more thing is, if you are, and I've made video about this, you can bring your tailstock manually by just using the knob, right? So you're gonna engage or retract. If you're gonna do manual program for the tailstock automatically engage, you go to setup info and you can set 2 positions. So as you see, it says tailstock unused. Even if you use it, and you engage it manually, I keep it on unused, because then you create a barrier. So every time the tool is gonna come down, it'll give you an alarm. So you have to input a barrier cancel on or barrier cancel off when you program it. And then you have 2 positions. You have position 1 or you have a position 2. What the position 1 and 2 it does is, once you're gonna manually bring your tailstock to the part, for example, you're gonna go to position 1, you're gonna hit the teach position, enter, you're gonna see a set of numbers. So later when you do automation of the tailstock will wrap it into the actually position 1. Right between the part is gonna slow down, and then it's going to the seek mode. Once it detaches the pressure or resistance, it's gonna beep. Then you're gonna see the green light light up, and your tailstock is gonna be ready to use. Same thing, when you're moving a tailstock and you're gonna go left, right for engagement, right for disengagement, it's gonna go fairly slow. But if right before you're gonna turn this left, if you're gonna press the MF1 with one hand, and with your second hand you're gonna turn this left and you have to hold it, the tailstock will wrap it. Okay, it will wrap it into the part and stop an inch or 2 inches or 3 inches before the part, because if you will not stop it, okay, give it a second and then engage it again. If you're not gonna do that, it will actually crash into the part, because when it's slow, it's seeking and it will stop. When it's rapiding, it's not seeking, so it will actually crash. So I'm moving left, right? Now you see it's blinking, and as you see, the tailstock is in engagement mode. It's very, very slow. Okay, so let's say I have a long way, so I want to speed it up. So it's a 2-hand operation. So what I'm gonna do is I'm gonna press the MF1, okay, and then I'm going to MF1. I'm gonna switch the I'm gonna switch the button, that knob, and as you see, now it's rapiding, and now I have to slow it down. If I wouldn't slow it down, it would crash. So I stopped it, and now I'm just gonna engage, and it comes in slow. It engaged, it beeped. Now you see green light on. And now if I want to, I can go to position 1, teach position, press enter. You're gonna see a value over here. So now the position and so the position, as you see, minus 37, verify, right? I'm gonna clear this because I'm not gonna use it. So now the tailstock is ready to use. But if you don't plan to do automation, if you just plan to bring it manually, then I wouldn't mess with it. I would just keep it as unused, because like I said, you're gonna have a barrier alarm on every time you're gonna come down with the tool, because the machine's gonna warn you that you have a tailstock engaged and then does not wanna crash into it. So that's why you use code 123. But you have to pretty much put that into like every single of your unit. So unless you're doing a high production, I wouldn't worry about it. Now you're done with the machining and whatnot, for example, right? And as you see, this one also, it has a thread for the bolt. So I would thread it all the way. I would keep it with a wrench, and then pretty much press it onto the face of the body, and then you do like maybe another eighth of a turn, and this will pop out. It will push it out, and then you can replace another one. So now what I'm gonna do, I'm gonna turn this right, for example, right? I'm gonna turn this right, and now you see that it's disengaging very slowly. Okay, So I'm gonna press 1 again. Okay, I'm gonna use the camera hand to turn the knob. And as you see now, it's rapiding back home. You can wrap it all the way back home. It's not gonna make any problems for you. You don't have to let it go before it gets home. So wrap it is okay. But when you wrap it towards the part, remember, stop before the part because it will crash into it and you can actually cause damage into the part or into your tailstock. These are like just pretty much manual, basic for tailstock, how that looks. Like I said, and you have this tailstock takes dead centers, so that means the center doesn't have a bearing because the actually body of the tailstock has set of bearings built into it, and these are very rigid and they're actually very good. Your centers with bearings in them, they're not going to be as rigid and maybe as good as the set of bearings that actually you find in these tailstocks. But sometimes you have to work with what you have to, like whatever it's available, right? So hope this is good enough information for somebody who's kind of curious how these things work. And like I said, usually what you do is if you have a ID hole, you use a center. Centers are usually 30 degrees. So what I mean by this is like they actually 60 degrees both ways or 30 degrees, and I'll show you let me see, as you see this angle, see they're a little bit more pointier than 45 degrees. So that's why when you have, like I have a center, I'll show you the difference. This is a 45 degree chamfer maker. So as you see, this is a little bit wider. The reason for that is it sits better with using these, and I actually use these centers for the threads as well, because I can use the center for the threads. And so see, there's a difference. This is your center. I don't know if you can focus, and this is your regular 45 degrees, and this is your 30 degree center drill. And the reason why, like I said, I use a center even for threads, because I still get a chamfer, but then I can actually bring a tailstock, support it, and it doesn't damage the actually threads. And I'll show you why. So imagine you have that 30 degree chamfer, right? And then your threads are here. So they're actually cut into this chamfer, where it starts, and the tailstock comes in here, right? So now when you're thinking about it, it's actually not putting the threads because it's sitting flush with them. So you can retract your center and your thread will go in. So sometimes you can, if it saves you from doing extra operation by using a chamfer or starting for tapping, for example, just use a regular center, just big enough, like I said, and then you can actually bring your tailstock supported and you can cut your part, and that way, you don't have to, like I said, go back, into for another operation and just to finish the thread because, you're done with supporting the part. All right, guys, thank you for watching and see you next time.